Welcome, students. Today, we are diving into an exciting Class 4 maths topic. We are going to learn all about factors and multiples. Let's get started. Did you know that every number leaves a trail and hides a secret? Have you ever noticed how numbers are connected? For example, when we skip count by 2, saying 2, 4, 6, 8, 10, a special pattern starts to appear. When we try to make equal groups, some numbers fit perfectly together, while others leave pieces behind. Let's uncover these number secrets together. Let's start with our first big question. What is a factor? Simply put, factors are the numbers you multiply to get another number. They divide a number completely without leaving any remainder. Imagine we have 16 dancers who need to perform on stage together. How can they be grouped equally? We could have one group of 16 dancers, since 1 times 16 equals 16. We could have two groups of 8 dancers, because 2 times 8 equals 16. Or we could have 4 groups of 4 dancers, since 4 times 4 equals 16. So 1, 2, 4, 8 and 16 are all factors of 16. There are two main methods to find factors. By multiplication. To find the factors of 24, we think of what pairs multiply to 24. We have 1 times 24 equals 24, 2 times 12 equals 24, 3 times 8 equals 24, and 4 times 6 equals 24. This gives us the factors 1, 2, 3, 4, 6, 8, 12, and 24. By division. We can also divide 24 by numbers to see if they fit perfectly. We do 24 divided by 1 equals 24, 24 divided by 2 equals 12, 24 divided by 3 equals 8, and 24 divided by 4 equals 6. They are exactly divisible. Remember these three golden rules. 1 is a factor of every number is its own largest factor, and a number has a limited number of factors. Now, let's talk about multiples. A multiple is the product of a number and any counting number. For example, in 7 times 8 equals 56, the number 56 is a multiple of both 7 and 8. If you look at the multiples of 2, we get 2, 4, 6, 8, and 10. Multiples of 11 include 11, 22, 33, 44, and 55. Here is a brilliant exam tip. To check if a number is a multiple of another, divide it. If the remainder is 0, it is a multiple. For example, 93 divided by 7 leaves a remainder of 2. So 93 is not a multiple of 7. What happens when numbers share things? Let's find the common factors of 9 and 15. The factors of 9 are 1, 3, and 9. The factors of 15 are 1, 3, 5, and 15. So, their common factors are 1 and 3. Now let's find the common multiples of 6 and 8. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, and so on. The multiples of 8 are 8, 16, 24, 32, 40, 48, and so on. Their common multiples are 24, 48, and they keep going. Let's review the different types of numbers we use. Natural versus whole numbers. Natural numbers are our counting numbers starting from 1. Whole numbers are just the natural numbers plus 0. Even versus odd numbers. Even numbers love to share equally. They are multiples of 2 and always end in 0, 2, 4, 6, or 8. Odd numbers, on the other hand, always have 1 left out. They are not multiples of 2 and they end in 1, 3, 5, 7, or 9. Now for prime versus composite numbers. Prime numbers. These are natural numbers greater than 1 with only 2 factors, 1 and itself. Great examples are 2, 5, and 7. Composite numbers. These are numbers that have more than 2 factors. Examples include 4, 6, and 9. Here is a tricky fact that is missed by 90% of students. The number 1 is neither prime nor composite. Also note that 2 is the smallest prime number. How do we find prime numbers easily? We use a method called the sieve of Eratosthenes. In 250 BCE, a Greek mathematician invented this cool way to find all prime numbers up to 100 by sifting out the multiples like chaff from wheat. Let's look at the steps. First, cross out 1. Next, circle 2 and cross out all of its multiples. Then, circle 3 and cross out all of its multiples. Repeat this process for 5 and 7. The result? The remaining 25 encircled numbers are your prime numbers. Want to skip the long division? Let's use divisibility rules. For these numbers, you just look at the last digit. Rule of 2. The number ends in an even number like 0, 2, 4, 6 or 8. An example is 346. Rule of 5. The number ends in 0 or 5. An example is 155. Rule of 10. The number ends in 0. An example is 1860. And here is a handy hack. Any number divisible by 10 is always divisible by 5. For 3, 6 and 9, you have to do a little math and add the digits together. Rule of 3. The sum of the digits is divisible by 3. Rule of 9. The sum of the digits is divisible by 9. Rule of 6. This is the double agent. It must pass both the rule for 2 and the rule for 3. For example, look at 36. The sum of the digits is 3 plus 6 equals 9. It is divisible by 2 because it ends in 6. And 9 is divisible by 3, so it passes the rule for 6. Moving on to prime factorization. Every composite number can be broken down until only prime numbers remain. And no matter how you start, the final answer is always the same. Method 1 is the factor tree method. This uses visual branches dividing composite numbers until reaching primes. Method 2 is the division method. This involves repeatedly dividing by the smallest prime until the remainder is 1. For the number 36, both methods will give you the prime factorization result of 2 times 2 times 3 times 3. Finally, here is your cheat sheet to remember everything we learned today. Factors. Numbers that divide another number evenly with no remainder. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12. Multiples. The result of multiplying a number by an integer. Multiples of 5 are 5, 10, 15, 20, 25, and so on. Prime numbers. Numbers greater than 1 with only 2 factors, 1 and itself, like 2, 3, 5, 7, 11, 13, 17, and 19. Divisibility rules. Quick ways to check for factors. For instance, even numbers are divisible by 2, and numbers ending in 0 or 5 are divisible by 5. Great job today, everyone! We hope you have understood the topic. For more such content, explore EduRev app.